Chapter 1 is Introduction to Networks, Exploring the Network. In this unit, you should be able to explain how multiple networks are used in everyday life. You need to be able to explain the topologies and devices used in a small to a medium-sized business network, and explain the basic characteristics of a network that supports communication in a small to medium-sized business. You also need to be able to explain trends in networking that will affect the use of networks in small to medium-sized businesses. For Chapter 1, we're going to look at what's globally connected, what that means. We're going to look at LANs, WANs, and the Internet, the network as a platform, the changing network environment, and then we will summarize it. Since 1995, you can see from this diagram that networking has changed dramatically. We double every 13 years, from 95 to 2000. Most people had fixed computing. You had to go to the device you wanted to use. Then we began doubling every 1.4 years, and that's when the devices went with you. Then beginning in 2011, there's no way of telling exactly how quickly it doubled because it wasn't doubling in years anymore. That was the age of the devices. That's the Internet of Things. And now we're to the Internet of Everything. You have people, processes, data, everything at your fingertips. The global community, when we have networks, can be people who are sitting next to you, or it can be people who are video conferencing, as these people here are doing in this particular meeting. Networks support the way we learn. They support the way we communicate. They support the way we work and the way we play. If you think about it, you're always connected to someone, so you're always in a network. There are networks of many sizes. You have your small home network. You may have a small office or a home office network where there's more than one of you working in a location. But you also may be contacting people who work back at a corporate level. You have a medium to large sized network. And then of course you have the worldwide network. We have clients and servers. Here are two examples of networks. Here you have your switch, and this device switches the signals that are coming into it and helps navigate where the signals need to go. On this one we have an email server who controls your email, your web, and your file. We have peer-to-peer networks. In this example here, you have two computers who are connected together, and they're connected to a printer, and they are sharing the printer. Some of the advantages of a peer-to-peer network is that it's very easy to set up. You don't have routers and switches to contend with. It's not very complex. It's low cost, and it works well in a very small situation. Some of the disadvantages are that it's not centralized. It's not as secure. It's not very scalable. Once you start adding devices, the peer-to-peer gets more cumbersome. All devices may act as both clients and server, which can slow your performance down because it's not sure who's in charge. There are three categories of network components that you need to look at. You have devices, you have media, and you have your services. Your devices are the actual devices themselves, the hardware basically that's in place. Your media are how are these devices connected? Are we doing fiber? Are we doing wireless? Are we doing copper? What is the media that we're using? And then the services. Are you using email? What applications are you using? Those are your services. Some examples of your end devices. You have your computers. Well, those are your workstations, your laptops, your tablets, the file servers, the web servers. You may have network printers. Your phones can be an end device. If you're using voice over IP phones, those are end devices. They have an IP address. You have telepresence endpoints. You have your security cameras. You have your mobile handheld devices such as your smartphones and your tablets, like the wireless debit and credit card readers, um, and some barcode scanners as well. Those are your end devices. In our network infrastructure devices, you have your network access point. These are your switches and your wireless access points. You have internetworking devices, the devices that connect the networks together. Those are your routers. And your security devices, the ones who help keep your network secure. Those are your firewalls. Your network media. You have copper. Here's an example of what the copper wire itself looks like. And then these are how the connectors on copper look. You have fiber optics, and then the different fiber optic connectors, and then you have your wireless as well. Network representation, you need to study this. There are examples within course content. It also shows up in your packet tracer so that when you see your network topologies, you understand what is being represented. You have your end devices. You have your desktop computers, your IP phones, the laptops, your wireless tablets. You have your intermediary devices, and then you also need to know what it looks like for the network media. That way you understand what that topology you're looking at is actually representing at any given one time. The topology diagrams shows here's the physical. Where are things actually located? Here we can see that we have an Ethernet switch. You have your admin offices. We have computers and printers. We have some servers. We got multiplexes. We have our different classrooms. And the cloud here represents the internet. Our logical topology is showing you the IP addresses. It doesn't necessarily show you which rooms they show up in, but it shows you what IP addresses are associated with that particular topology. The two most common types of network infrastructures are your local area network, referred to as a LAN, and then we have our wide area network, and that is a WAN. There are other types of networks that can be included. You have your metropolitan area network, your wireless LAN, and your storage area network. Here's an example of a local area network. It's basically a network that is serving a home, maybe a small business or campus. It's considered a LAN network. You have your server. This particular one has a switch, and then the end devices are connected to it. Here we have a computer, here we have some workstations, and we have our phone. We have a wide area network, and these LANs are separated by geographic distance, and they're connected by a network known as a wide area network. This particular one has two routers. These two routers make up a WAN here. And then we have two LANs. We have this one, and we have this one. So in reality, we have one, two, three separate networks, but they're networked together. So these are sub networks. We'll get into subnets later in the chapter or in the unit. Here's the internet. If you think about it, the internet or the world of everything is connected. If you're on the internet at all, you are part of this large network. We then have the intranet and the extranet. The internet is the world. Your extranet that you may have set up with businesses are your suppliers, your customers, your collaborators. And then you may have an intranet, and that is company specific. We need to be able to connect our remote users to the internet. A home user may be connected through DSL, through cable. You may have a wireless or satellite hookup. You may have fiber optic running. Teleworkers and small offices are also connected to their internet service provider or ISP the same way as you at home are connected. When we have businesses, if the business is large enough, it may have a dedicated lease line. Those are expensive, so it usually takes a larger company. You have your Metro Ethernet, DSL, and satellite for ways that an organization may connect to its ISP. We have converging networks. Our converging networks are where multiple services are running on multiple networks and they work in conjunction with each other. They talk to each other and they work together. When you're planning a converged network, you have to keep the future in mind. And I know we don't know what's going to occur in the future, but you need to come up with your what ifs. Do you need to be able to expand? Reliable network, we need to be able to support network architecture. As our networks evolve, they're discovering that there are four basic characteristics that the underlying architectures need to address in order to meet the user's expectations. You need to look at your fault tolerance, your scalability, your quality of service, and security. The fault tolerance is whether or not your system is going to stay up. We have a circuit switching in the telephone network. If something goes down, what are you going to do? How are you going to keep your business up and going? In a packet switch network, you're going to send out that information. And for fault tolerance, you want to make sure that your packet, when it leaves your device and goes to the next device, that all of it gets there. So your packet or your email may be broken up into smaller sections, and each of those have its source address, its destination address, and its sequence number, because it's going to be split up and it's going to go multiple paths to get to its destination. Once it gets to its destination, it's going to put all of this back in order for everything to be there. We have scalable networks. That means that at each layer I'm able to enlarge. I've taken into consideration that I might need to grow my company. You need to take that into account. We want to provide quality of service. Some examples of an organization might include time-sensitive communication. If it's high importance, you may want to increase the priority for the services like your telephone or video distribution. You don't want all of your IP traffic being used up by a printer or another end device. If you're a call center, you need your calls coming in. Non-time sensitive communication, you might want to decrease the priority on that. Do your workers really need to be out surfing the web? Do they need to have their email immediately? Does it need to take precedence over the phone call that's coming in? Or perhaps you're in a web conference. You have to prioritize which service is taking up your resources. High importance to organizations, you're going to increase your priority for production control or business transaction data. You want that money to come in and do so timely, so that probably gets a higher priority than other things. Undesirable communications, you're going to want to decrease the priority or block altogether any unwanted activity like peer-to-peer file sharing or live entertainment. Perhaps you do not want your workers streaming the latest movie. You need to also provide network security. How are you going to keep your information safe? How are you going to keep identity theft and criminals out of your system? And how are you going to protect the information that's already within your system? You'll do that through having firewalls. You're going to want to have your policies in place. How do you handle things? What are your clients allowed to do? And then you have data encryption. You want to be able to safeguard the information that you do have and that you're sending. Some of the new trends that are going on in the office place today and in education, you have bring your own device. This saves companies money because they're not having to constantly replace equipment if you already have your own. You have online collaboration. This cuts down on travel expenses. We have video, and then we have cloud computing where we're not having to maintain the servers ourselves. We'll let the company that hosts our cloud maintain the equipment. With the cloud computing, you have public clouds, private clouds, custom clouds, hybrid clouds. How many of you live in the cloud? Another new trend are our data centers. Here in North Carolina, we host several data centers. Close here to the community college is Facebook's data center up in Forest City. So there are data centers around. The data center is a facility used to house computer systems and its associated components. There are redundant data communication connections. There are high-speed virtual servers. They're not physical servers, they're virtual. There's redundant storage. There's redundant power supplies. There's redundant backups. There's redundancy built in any and every place that they can have it. They have environmental controls, and there are security devices in place. Some of the technology trends in the home is you may have your house, it may be a smart home. Do you control your thermostat from your phone? Can you open and close your garage door from your home or from your device? Can your car talk to your house? There is power line networking where we can pull some power and some connectivity through our power lines. You have wireless broadband. We need to pay attention to network security. You have threats to your network. You have external threats. Those are people who are trying to get in and get your information, or they're trying to get in and use your devices to host their information. And then you also have internal threats if you're a business. Do you have an employee who's disgruntled, who's trying to get back at you by getting rid of your information? The most common external threats to the network are your viruses, worms, and trojans that can come in via email. You have spyware and adware. You have zero-day attacks, also called zero-hour attacks because they happen so quickly. There are hacker attacks, denial of service attacks. That means that everything's getting hit so much and so often that the system doesn't have time to do the legitimate work. You have data interception and theft, and then you have identity theft. Some of the network security components that are often included in your security solutions is you have antivirus and anti-spyware. You have firewall filtering going on. You may even have a dedicated firewall system. Your system may have an access control list, who gets in, who gets out. You have an intrusion prevention system set up, and you may be working in a virtual private network. With the Cisco network architectures, you have collaboration, there's data center and virtualization, and borderless networks. The Cisco Certified Network Associate, which I'm hoping you each work on, we have different levels. You have your entry CCNA, there's the associate, there's professional, there's expert, there's an architect. There's many different levels of CCNA that you can achieve. So make sure that you've paid attention and that you understand networks and the internet have changed the way we communicate, how we learn, we work, even we play. Networks come in all sizes. They can range from simple networks consisting of 2 computers to networks connecting millions of devices together. The internet is the largest network in existence. In fact, the term internet means a network of networks. The internet provides the services that enable us to connect and communicate with our families, friends, work, and interests. The network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur. It's made up of the network components including end devices, intermediate devices, and network media. Networks must be reliable. Network security is an integral part of computer networking, regardless of whether the network is limited to a home environment with a single connection to the internet or has large corporation with thousands of users. And finally, the network infrastructure can vary greatly in terms of size, number of users, and numbers and types of services that are supported on it. The network infrastructure must grow and adjust to support the way the network is used. The routing and switching platform is the foundation of any network infrastructure. And as this semester goes on, we will get more and more in depth with our routing and switching. You will actually get your hands on some routers and some switches. You'll do a little configuration. Don't let that scare you. We will take it bit by bit, and I hope you enjoy the ride.